Day 15 of 90 in our Go challenge, and today we fixed the bug that wakes you up at 3 a.m. Picture this: your microservice returns a 500 with the message internal error. You open the logs. Nothing useful. Just something went wrong. Somewhere 3 layers down, Postgres rejected a duplicate key, but by the time that error reached your logs, every shred of context was gone. Today we make Go's error handling work for you, turning naked errors into a full crime scene you can actually read. Here's the thing developers miss: Go's explicit if error equals nil isn't tedious busywork, it's a design tool. Every error is a value you get to enrich. The problem is return error. That bare return is a lie by omission. It says something failed but erases where. The fix costs one line. Instead of return error, you write return fmt-longform \fetching user %d, %w \id error. That %w verb wraps the original error, preserving the whole chain while adding your layer of context on top. Why %w and not %v? Because %w keeps the original error reachable. You can still pull it back out with errors.is and errors.as. Let's see it. Say your repository layer defines a sentinel, var error user not found equals errors a new \user not found \. Deep in your code you wrap it, fmt-longform loading profile, %w error user not found. Then up in your handler, even after 3 layers of wrapping, errors.is error user not found still returns true. You match on identity, never on fragile string comparison. Now, when do you use a sentinel versus a custom type? Sentinels are for simple yes or no questions. Is this not found? Is this rate limited? But sometimes the caller needs data from the error. That's when you build a struct. Define a repository error that carries the operation name and the entity ID. Give it an error method so it satisfies the error interface, and an unwrap method so the chain stays intact. Now your error isn't just a message, it's a structured fact the caller can inspect. Here's where the struct pays off. In your HTTP handler you use errors.as. You declare var repo error * repository error, then call errors.as here repo error. If it matches, you get the typed error with all its fields populated. Now you can branch intelligently. A not found becomes a 404, a unique constraint violation becomes a 409, a dropped connection becomes a 503. One error value, 3 different decisions: retry, abort, or degrade, and 0 string matching anywhere in sight. This is the service boundary translation layer, and it's the most important idea today. Your internal errors are rich in detailed operation names, entity IDs, the full wrap chain. But your wire protocol should not leak that. So at the boundary, you translate internal repository error maps to a clean gRPC status code or HTTP status. The client gets a 409 conflict, they never see your table names or SQL. Implementation details stay inside, the contract stays clean. Rich internally, minimal externally. And the logs, this is the payoff. Use slog to log the full chain at the boundary, slog error, \request failed \, \trace _ID /ID, \error error. Because every layer wrapped with %w, that single log line now reads top to bottom, handler, loading profile, querying users, PQ, duplicate key value. You see exactly where it broke and why. For fanout work, errors join aggregates partial failures from concurrent coroutines into one error you can still unwrap and inspect piece by piece. So the recipe: wrap with %w and fmt-longform at every layer to preserve context. Use sentinels for simple checks with errors.is, custom structs for rich decisions with errors.as. Translate internal errors to clean status codes at your service boundary. And log the whole chain with slog. Do this, and that 3 a.m. page goes from internal error, good luck, to a 409 with a trace ID and a readable stack of exactly what happened, debuggable in seconds, not hours. Day 15 done. The takeaway: a wrapped error is a gift to your future self at 3 a.m. Subscribe for day 16.